right, so we are looking here at these trigonometric ratios. Oh my gosh. Have you seen these words before? Sine, cosine, tangent. Have you heard them and seen them? Do you know about them? Well, guess what? I bet for ages, if you haven't ever heard of these words before, have you ever wondered on a scientific or graphing calculator, I'm sure you've seen these buttons that say sin, cos, and tan. Have you known what they're for? Well, today's the day, my friends. You finally get to learn what those buttons are for. Sin is not really sin. It's short for sine. So you would say that out loud as sine. COS is short for cosine, and then tan, short for tangent. What in the world are these things? These are just ratios of two sides of a right triangle. That's literally all it is. If you just take two sides of a right triangle and reduce that ratio or turn it into a decimal, that's what the sine, cosine, and tangent are. Now, it's specific on which sides you compare to each other. So we have a magic word to help us remember it all. Have you heard of the word Sohcahtoa? No? No one's ever heard of that word before? Sohcahtoa? Sohcahtoa. Sohcahtoa, like you're literally like you're gonna soak your toe in something. Sohcahtoa. Let me show you how to spell it and let me kind of break down what it means. So this whole section, I promise it makes a lot of sense once you start practicing them, and then you're like, oh yeah, okay, I get all of this. All right, so first of all, let's start with the magic word. Sohcahtoa is spelled, oh gosh, there's not enough space. I need more space. I don't even know if I'm going to use this, to be honest. You can, if you want. I can't. I'm going to use my fancy notebook. That's why I have it, right? To use it. To you, but I can't be confined to the margins of this paper. I feel like a bird trapped in a cage. I have to spread my wings. And I just can't. On this little piece of paper. Okay. Sorry, all my pages are used up, so I have to click them. All righty. So, trig ratios, Sohcahtoa. Here we go. Five, 8, 6 trig ratios. All right, friends, magic word, Sohcahtoa, here it is. Sohcahtoa. Sohcahtoa. And it is crucial that you spell it right. Sohcahtoa. All right, now let me break down what each of these things means, okay? Because I know it's super confusing right now. I'm going to draw a right triangle over here. And I'm going to label it with vertices ABC. Okay. All right, so this first chunk of the word, so the S stands for sine. So we'd have sine, or we get lazy and we abbreviate it as SIN. And now I'm going to introduce you to another new thing. We have a variable that we like to use just for angles. Okay, like we use X all the time just for a missing letter. You can still use X, but it's very common to use the Greek letter theta for a variable for an angle. Okay, why? I don't know, but we do it all the time. So I want to introduce you to this symbol if you haven't seen it before. You might have, it's called theta, and people draw it a little bit differently. I kind of do it like this. I do it kind of like a circle with an extra kind of loopy. Some people kind of do it like this, kind of like with more of a line through it. It's not this though. I almost don't want to draw it because I don't want you to get it in your head. I'm going to draw it and then erase it. Okay, it's not this. That means that there's no answer. Okay, so it's not that. It's different than that. Theta. And it's just a Greek letter. And we're just using it as a variable. Okay, so it works like a variable. It's just like using X, but we use it for angles. So I'll just add that as a variable for angles. Okay, so sine of some angle theta is going to be equal to, you ready for this? The O stands for the opposite side. Over, what do you think H stands for in a right triangle? Hypotenuse. I know right now, none of this makes any sense. And you're like, I have no idea what you're talking about. Trust me, it will make sense in just a few short minutes. So sine, and that's sort of how this chunk of the word helps you out. It lets you know sine is going to be the O, opposite side, over H, the hypotenuse. Ka, my middle chunk of the word. So the C already stands for cosine, as we said. Cosine, or COS, that's our abbreviation for cosine. So again, cosine of some angle is going to be equal to A over H. If O was the opposite side, you want to take a guess what A must stand for? If O is opposite, A must be, oh, good guess. Give me another word that starts with A that we had in our mix, Isabella. Adjacent. Adjacent. So we're going to take the adjacent side. Again, H stands for the hypotenuse, and I'll divide it by the hypotenuse. And then I ran out of space for my tangent, but that's okay. I'll just put it here. Tangent, or tan, of some angle is going to equal, now you know what O and A stand for. This one's just going to be the opposite over the adjacent. I know what you're thinking. Okay, I know how to tell who the hypotenuse is in a right triangle. That's always the one across from the 90-degree angle. But who's the opposite side and who's the adjacent? It depends on what angle you're talking about. Okay, we will never be talking about the right angle. We'll always be talking about one of the two acute angles. So it's going to change who's the opposite and who's the opposite and adjacent, depending on what angle we talk about. So let's do some examples so we kind of understand what in the world is going on here. Okay, everybody has these three ratios written out though, right? I'll give you another couple seconds while I draw our triangle down here. All right, let's give this a whirl. So I've drawn another triangle down here. This is only for right triangles, by the way. So you can only use these ratios in right triangles. All right, so here's a triangle. So here's what I want to do. I want to find the ratio that each of my ratios represents, okay? So number one, if I wanted to find, let's start off nice and easy. The sine of C, angle C. It's going to be equal to something over something. Now, here's what we do. Sine of angle C. So first of all, I figure out where angle C is. It's right here. Right? So I'm even going to, don't mark it in yours, but I'll mark it in mine because I can erase. Now, according to my magic word, Sohcahtoa, right? Sine is equal to the opposite side over the hypotenuse. So if I'm looking at angle C, I want to figure out who's the opposite side and who's the hypotenuse. I have three sides in every triangle, right? Of course I do. The hypotenuse is always the hypotenuse no matter what. That's never going to change. Which side is the hypotenuse here?
The one across from the right angle, the one on the right.
Yeah, how would you name it? Name it. It would be side BC. Side BC is my hypotenuse, right? And that will never change. That is my hypotenuse. Now, if I'm talking about angle C though, one side is going to be opposite of this angle. And which side is that in this case? BA, right? Isn't that the side opposite that angle? So this would be my opposite side. And then if I needed the adjacent side of angle C, wouldn't that be this side right here? What's adjacent mean again? Right next to, yeah. So there's always going to be two sides right next to the angle, but one of them is always going to be the hypotenuse. So the other one that's right next to that angle, we refer to as the adjacent side. So if I wanted to complete this ratio, the sine of angle C is just going to be the opposite side, which in this case is BA, over the hypotenuse, which is BC. Normally, these will all be numbers, okay? So kids always get so confused about what sine, cosine, tangent is. It's literally just a number. It's just the length of two sides of a triangle divided with each other. It just comes out as a decimal. We'll do plenty of practice with numbers in just a minute. Yeah.
So when you're deciding like the opposite angle, why use angle C instead of like B?
That's what I picked. We could do, I could ask you for the sine of B. I will ask you for the sine of B in a minute, and that'll be different than the sine of C.
So it could be either or.
Yep.
Okay.
All right. Before I move away from angle C, let's talk about the cosine of angle C. So if you look at your magic word spelling up here, CAH, cosine is equal to the adjacent side over the hypotenuse. So I already have my sides labeled. I'm still talking about angle C. So hopefully you can figure out the adjacent side over the hypotenuse. You got it? What's my adjacent side? Everybody. AC. And I would divide it by the hypotenuse, which of course is still BC. Again, these are going to be numbers in a few minutes. And then I could literally just like find what the number is. And we might as well finish off and talk about the tangent. So tangent is going to be opposite over adjacent. So that's got to be side what over what? BA over AC. Now, watch how things change when instead of focusing on angle C, I focus on angle B. So I'm going to erase these things because now I'm not going to talk about angle C anymore. So the hypotenuse is not going to change, but the opposite and the adjacent sides are going to change, aren't they? If now I'm focusing on angle B, right? If angle B is the one I'm looking at, which side is opposite now?
AC.
AC. Does everybody see that? We're okay. So now this is the opposite side, and then obviously the adjacent side would be right here. So when I go to ask you the sine of angle B, it's different than the sine of C for the same triangle, right? I'm in the same triangle. I didn't change anything about this triangle. I'm just now changing my focus of attention to angle B instead. I'm still going to do opposite over hypotenuse. But what does that come out to for this? AC over BC, correct. Now that's my opposite over my hypotenuse because I've changed my angle. I'm looking at a different angle now. Okay, so go ahead and try cosine of angle B. And lastly, do tangent of B. I'm looking at the note sheet, and so it's basically the same thing. They just labeled their triangle. I have mine as A is the right angle. They have it as C is the right angle. So if you're doing the note sheet here, you could do it for that triangle too. Same idea though. Okay, cosine B is BA over BC, and the tangent would be AC over BA. How's that? Are we okay so far? Please tell me if you're lost or if it doesn't make sense. All right, all right, all right, all right. Let's try with some numbers now, okay? We'll throw that in. So let me see what I can do right here. I'll do the instructions as find the following ratios. I'm going to give new letters now. How about L, M, N? And let's say, let's do a 5, 12, 13 triangle. Okay, so, and I'm just going to give you some random things. Find me, let's do sine of N. Let's do cosine of L. Let's do tangent of L. And maybe sine of L. Oh no, I focused too much on. I'm going to change it to tangent of N. You didn't get to number 3 yet, did you? Let's try finding these 4 ratios. Okay. We got some? All right. Who's got number 1 for me? Sine of N. Raise your hand. Who's got it? All right, Sam, go ahead. What's sine of N?
12 over 13.
Yes, opposite over hypotenuse. 12 over 13. Check what you wrote. Did you write 12 over 13? Oh, good. You're doing swimmingly. Cosine of L. Someone give me this one. Cosine of L. Oh, come on now. Cosine of L. Cole, go ahead.
12 over 13.
It is also 12 over 13. Isn't that interesting? Even though I'm now doing adjacent over hypotenuse, but for angle L, the adjacent side is 12, the hypotenuse is 13. Interesting, right? Okay. Did everybody get that one? You got 12 over 13 again? Okay. Tangent of N. Patrick, go ahead.
12 over 5.
Opposite over adjacent, 12 over 5. Perfect. Did you get 12 over 5? If you're looking at angle N, the opposite side would be 12, the adjacent side is 5. Again, you might be thinking, well, the adjacent side, how do you know it's 5 and not 13? Because 13 is the hypotenuse. Hypotenuse will always be the hypotenuse no matter what. Okay, and then last one, the sine of L. Go ahead, Carson.
5 over 12. Or no, 5 over 12.
Yeah, 5 over 13, opposite over hypotenuse. So do you see how the magic word helps you set all this up? If you know that word Sohcahtoa, you can then, you know which ones go over, right? You know, okay, sine has to be opposite over hypotenuse. Cosine has to be adjacent over hypotenuse, and tangent is opposite over adjacent. Yeah? So far, so good? Okay, now what in the world do you use this stuff for? Let me tell you. Oh my gosh, so much. I have to erase another page. That's the only downside to this notebook. Although it's kind of a good side because you're like reusing, saving the earth one piece of paper at a time, right? Okay. What can I use Sohcahtoa for? That's a great question. And there's 2 great answers. If you have 2 sides, or I should say at least 2 sides. Oh, you know what? Let me do that 1 second. Let's do, if you have one of the acute angles of a right triangle and the length of one side. Any side, literally any side. You can find all of the other parts. So there's one thing you can do. This is so cool. And that's what we're going to practice a little bit with that once I tell you the second cool thing you can do with it. So my claim is that from now on, if you are given a right triangle, right, it has to be a right triangle. You can't use Sohcahtoa on anything besides a right triangle. Okay. If you know just the measure of one of those 2 other angles, you have to know the 90-degree angle, of course, otherwise it's not a right triangle. So if you know the measure of just one of them, okay, let's say it's, I don't know, pick a number from 1 to 90. 80, sure. Say we know that this angle is 80 degrees. Obviously, I could find the third angle. That doesn't require any special skills. But now my claim to you is if you know one of those angles and one of those three sides. I don't even care which one. Let's say you want, give me a number. 13. Okay, let's make the hypotenuse 13. I claim you can find the lengths of the other two sides of this triangle with just this information. So think about what we needed before. If I have two sides, I can find the third by using Pythagorean theorem, right? But I don't have two sides, I only have one side. So I can't use Pythagorean theorem here, right? That's not going to help me. So right now, I don't have any other skills to find the lengths of either of the other two sides. But Sohcahtoa is the key I've been looking for to unlock this door. Aloha Mora. Here we go. You ready? Well, hold on. I'll tell you the other second thing and then I'll show you how to do this. Oh my gosh. Okay, so I'll just give you a preview. Now we can find the lengths of the other two sides. Again, I'll show you how to do that in just a minute. But let me tell you the other fun thing that Sohcahtoa does, and that skill we'll practice probably tomorrow. Okay, so the other thing we can do is, or let's say I don't know any of the other angles besides the 90-degree angles. So if I know two of the side lengths, of a right triangle, I can find the angles. That's something. So let me show you just a little preview example. So again, we'll probably talk more about this tomorrow. But let's say all I know is the right angle. I don't know any of the other angles, but I do know two of the side lengths. So, I mean, they could be anything. Let's say this is, I don't know, you're 6 and you're 11. Who cares? If I know that, yes, you can find the third side by doing Pythagorean theorem. That's old news. But now what I'm telling you is you can actually figure out what the angle measure is in degrees with just that information. Oh my gosh. Now you can find the missing angle measures. What? I know, it's so cool. So that's what we can do with this. So let me show you a couple of examples of the first skill, okay? And you are all going to need at least a scientific calculator. Do you have one? Go grab one if you don't have one. You can use graphing too if you want, but you need one, a calculator that has the sine, cosine, tangent buttons on it. So I'm going to do the example up at the top that I started. So my claim is that there is a way that you can find the two other side lengths. You can only find them one at a time. Which one would you like to solve for? BA or AC? Okay, sure. So I'm going to call that one X. So if I'm doing a problem like this, I'm going to give you some little step-by-steps here. So step one, figure out what ratio you need. So are you going to use sine, cosine, or tangent? Now, how do you do that? Well, bless you. Here's the angle that I know about, right? So I'm focusing on this angle. Yeah, I could figure out what angle B is, but why? I already have angle C. Now, if I'm focusing on this angle, which side is this one that's marked 13 out of opposite, adjacent, or hypotenuse? What is that one? What is it?
13.
Yes, that's the hypotenuse, right? So I kind of like to label them. You don't have to, but so there's my hypotenuse. So I'm certainly going to use one of the ratios that has the hypotenuse in it. Because I have that, right? So I'm not going to use tangent. Why would I use that? Because that one doesn't involve the hypotenuse at all. Now, I don't care about AC right now. I'm not trying to find it. I don't know its value. So I'm kind of just going to ignore it. This is the side that I'm trying to find. What side is that out of opposite, adjacent, or hypotenuse? If I'm talking about this angle right here, that side would be the opposite side, right? So this is the opposite side. So now it's up to me to go back to my magic word, Sohcahtoa. The two sides I care about in this problem are the opposite and the hypotenuse. So which of my three ratios is it? Sine. Sine is the one that deals with opposite and hypotenuse. Cosine is adjacent and hypotenuse, and that's not what I have. And then tangent was opposite and adjacent. I don't have that either. So there's always going to be two sides that I care about. I don't care about this third side right now, so it's irrelevant to me. There's always two sides that I care about, and those two sides will determine which of these three I'm using, whether it's going to be sine, cosine, or tangent. Does that make sense? Everybody's okay? So once you figure out which of the three you're even using, step 2, fill in the ratio. So we know that sine of my angle. So here's what we wrote in on the other page. Sine of some angle is equal to opposite over hypotenuse, right? That's like the generic formula. I can fill this in with stuff. I know some of these answers. Are you ready? Or not? Hold on, I'll give you a minute. Some people are ready. I don't want you to see this magic unfold in front of your eyes. I don't want you to miss a thing. Okay, ready? Check this out. So sine, I know what the angle is. I know it. It's 80 degrees. So I'm going to replace theta with an 80. I know what my angle is. Sometimes I won't, but this time I do. The opposite side, what is that? It's x. So an x goes right there. And then the hypotenuse is just the 13. This is now an equation that you can solve, believe it or not. But Mrs. Savia, I have no idea what the sine of 80 is. I know you don't know, but your calculator knows. It's just a decimal. It's not a decimal that you're ever going to be expected to memorize. In fact, I'm going to give you a table in a minute that has them all listed. But you will always be given that information. You don't have to know, you don't have to memorize what the sine of any numbers. Oh, I take that back. I'm sure when you get to pre-calc, you'll be memorizing certain ones.
Is it 0.98480775?
Well, hang on one second, because we got to make sure. There's another weird thing about calculators. All right, so everybody has a calculator, right? Can you, now I see we have some different brands out there. See on my screen, I don't know if you can see it, but right there, there's a little tiny set of 3 letters that says DEG. That stands for degree. So look on yours. Yours probably says DEG somewhere, maybe not in the same spot. But that's, there's different there's different modes that the calculator could be in. And in order to make sure that all of our trig ratios are right, we need to be in degree mode. Because again, when you get to pre-calc, you'll start talking about radians, and then those give you completely different numbers. So if you're in radians, so if your calculator says rad, R-A-D, that's radians. You don't want radians, you want degrees. So if you don't, does anybody have a screen that doesn't have anything on it?
Wait, so it's supposed to
It's supposed to say DEG. Degree.
DEG?
Yeah, or maybe D, or just not RAD. It's a bad one. But another thing you can do to double check this, there's always going to be a mode button. So if you find the mode button, ours is right next to that green one. If you look at the, so on mine, the very first row, DEG, RAD, or GRAD, you just need to make sure you're in degree mode. So you'll touch radians and pre-calc, but make sure you're in degree, okay? So let's try it. Now that we are sure that our calculator is in the right mode. By the way, when you set the calculator in a mode, like it'll stay there forever until you change it. But it's always a good idea if you're using like a school calculator, because you don't know what the last person did in the last class. It's always a good idea to just check and make sure that you're in the right mode. Yeah. Can I see it? So all we have to do to figure out what that decimal is for sine of 80. You got here, see it's a D right there.
Oh, it's just a D.
Mhm. And I bet you have a mode somewhere.
This is shit.
Oh, right there. Well, anyway, you're in degree, so just leave it at degree and you'll be fine. Okay, so we're literally just gonna hit, what do we want? Sine of 80?
Yeah.
So we hit the sine button and then it'll say, okay, sine of what? We just type in 80. It's a good habit to get into to close your parentheses. It's not even that big of a deal if you don't. If you hit enter, there's always gonna be some crazy long decimal. Super long, right? All I need to do to solve for x, wouldn't I just times it by 13? Right? So I can literally just take my answer as it is and just hit times 13. You don't have to retype that decimal and then hit enter.
12.8015007.
So everybody make sure that you got the same thing that I got. 12.80 blah, 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 blah. Did you get it? If you got it, then your calculator is in the right mode and you did it correctly.
Wait, can we do that?
Sure. You're going to hit the sine of 80, close your parenthesis. You can hit times 13 right here if you want. Just make sure you close the parenthesis first. Or you can hit, so do you want to, you can just hit times 13 right there. Okay, so you just found the length of this third side, which makes sense too, by the way, right? Because I know that my biggest side is 13. So whatever this side was gonna be should have been something less than 13, and it is. So we're gonna round that to be 12.8. So we'd say x is approximately 12.8. Oh my gosh, that's so cool. Let's try another one. I thought you'd never ask. What if, let's just stick with the same exact triangle. Let's now find, let's find this other, I know you can do Pythagorean theorem, but let's not. Say you want to find this side now. Using a trig ratio. Let's not use Pythagorean theorem, okay? So we're not going to use the answer we just got for x. So we're going to imagine that that's the one that I have no idea about.
We don't have the angle B.
You don't need it. You got this one. So now let's go back. Oh yeah, fill in the ratio. I guess step 3 is, let's do fill in the ratio and solve. And then there's step 2 and 3 kind of together. And then you're pretty much done. All right, so let's go back and we'll do step 1. So now if this is my scenario, I still have angle C. This is still the hypotenuse, but now what side is this one over here? That's the adjacent side. So now which ratio are you going to use? Cosine. Cosine is the one that has adjacent and hypotenuse involved. You see that? So now I'm going to do the cosine of my mystery angle is going to be the adjacent over the hypotenuse. According to my magic Sohcahtoa word, right? And now I can fill in the pieces. So I know I'm going to use the cosine ratio. Now I know a whole bunch of this information. I know the measure of my angle, it's 80. The adjacent side is y, and the hypotenuse is 13. So now I'm going to grab my calculator. I'm going to do basically the same thing, except this time I hit, Sorry. What do I hit instead? Cosine. Because I'm dealing with the cosine ratio. So I'll hit cosine of 80, close my parenthesis, and then I'm just going to multiply it by 13 in this case, right? So I can do it right in the same step if I wanted. Did you get what I got? 2.26 if we round it. Isn't that neat? Does it get harder than this for this skill? A little bit, not really. I mean, I'm going to show you, there's one little thing I definitely want to have to flip the page. Does everybody have what they need for this before I turn it? Okay. I just want to show you what happens if the thing you're looking for is in your denominator. And I think tomorrow I will give you, we don't really have much time. So tomorrow I'll give you the chart that has all of these decimals on it. But if you have the calculator, you might as well just use the calculator, right? Okay. My sunscreen fell down. All right. That's good. Okay. So new triangle. Here's my right angle. Let's say this time I'm looking for that. Let's make this a, I don't know, you could be a 20-degree angle, whatever. And how about this side is, who cares? It really doesn't matter. 8. So we were going to do this. Step 1, I asked myself, which of the 3 ratios am I going to use? I can't really figure that out until I figure out what sides I have and I care about, right? So this side that's marked 8. If I'm talking about this angle right here, what is that out of the 3? Is it opposite, adjacent, or hypotenuse? Opposite. Does everybody see that? Do you know where we're coming up with that from? All right. Hold that thought. Come on, Miss Savia. Sure. Yes, thanks. Bye. Okay. I'll see you tomorrow. You're missing a gem here. Okay. All right. So what do you guys say 8 was? 8 was the opposite. And then the other side that I care about right now is the hypotenuse. I don't care about this side down here, so I'm going to ignore it. I'm not trying to find it. I don't have value. Ignore it. So since I'm dealing with opposite and hypotenuse, that means the ratio I'm using is? Yes, sine. So sine of some angle is always opposite over hypotenuse. That's what we get from the magic Sohcahtoa word. Now I can fill in the pieces and solve. My missing angle, I know it's not missing. I know what it is. It's 20. The opposite side is 8 and the hypotenuse is x. Are you with me so far? Now, I can't just do sine of 20 times 8 on my calculator. That's not the same thing at all, is it? No. But what you can do, if you remember from our ratio chapter, what was that, the last one? I don't remember. Can't you swap any pair of diagonals? Couldn't you take, right? Couldn't I just pretend that this is over 1? And couldn't I just swap these two? So x is actually equal to 8 divided by the sine of 20. Do you see what I did there? I just literally took those two and swapped them. And now I can do that on my calculator. So I just grab my calculator. I'm going to do 8 divided by the sine of 20. What'd you get? Yeah, 23.39. Did everybody get the same thing? If you don't like that, which is, I mean, that's fine. You can just figure out what that decimal is, sine of 20 all by itself. And then usually when we're dealing with these decimals, we don't use the entire decimal. We go out 4 places. So if you wanted to ever just use the decimal, just go out 4 places. And then you could just do the math from there. You're going to get the same thing, but it's so much easier in my opinion. If you remember, oh yeah, I could just swap diagonals. So boop, I'll just do 8 divided by sine of 20. And that gets me, x is approximately, what do we say? 23 point something. 23.4 if I'm going to round to the nearest 10. It's nice to check that my hypotenuse certainly should have been bigger than my side, and it is. It doesn't guarantee me that I'm right? There's lots of numbers that are bigger than 8, but I at least know if I got a number less than 8, I automatically know that I'm wrong. How do we feel about this? Okay-ish? All right, so what I'm going to do is I'm not going to assign you any specific homework tonight. I'm going to let this marinate. Tomorrow I'll talk to you about the other skill that we mentioned, and we'll do lots of practice tomorrow, okay? If you could return the calculators, that would be helpful. I'm sorry, I went off road here. I didn't use those notes at all. I can't be restricted.